Hello friends, welcome to our channel. Let's have a look at problem 441, arranging coins. In this video, we are going to explain two solutions. Let me make some remarks here. So the plan will be two solutions. The first one is a routine one, just by a while loop. The second one will be binary search. For this problem, actually, if you could solve it using while loop, that would be sufficient, because the problem is marked easy. However, this problem actually suits a binary search pattern. So here, basically, we have a number of coins, and we want to build a staircase with these coins. And the stair consists of key rows, where ith row has exactly I coins, and the last row of the stair might be incomplete. So we want to return the number of complete rows of the staircase you are going to build. So for example, here you have 5, right? So the complete rows will be 2. But if you have 6, it should be 3, right? You can look at this 6. But if you have more than 6 but less than 10, you're going to get 3, all 3, right? So here, actually, if you think of this statement, actually you can quickly write a routine one. Let me first write a routine one. So here I'm going to use a while loop, and I'm going to check the counts left, right? And also the current number of counts in the row, right? So initially set to be n and 0, right? So basically, while left is greater than an I, right? So here initially is 0, right? So what we are going to do, we're going to first increment this I by 1. The reason I increment because I set I to be 0 at the very beginning. And then I'm going to do decrement this by I, right? And then later we just need to return I, right? So this is the full rows you can finish. Let's run it. It passes the cases. So now let's look at the binary search solution, right? So here, if given a number n, right? So we can make some guess. For example, if you guess 1, so it should work if n is greater than or equal to 1. But if you guess a large number, for example n, it's not true, right? And then we don't need to check one by one. Like we check the middle, and then we check if the middle is true, and then we check the upper half or lower half. So this is exactly the binary search pattern scheme. So first we're going to define a Boolean function, right? And then I'm going to do search range, search space shrinkage. So let's carry out that. I'm going to copy this part and put it here. And I'm going to call this one version v1. So now this one is based on binary search. So first I'm going to define a Boolean function. So basically I want to check if we have key complete rows, how many counts we have. So, or if we can have key complete rows, right? So here I'm going to return. So if you have a 1, you add 1, 2 up to key. So the sum will be 1 plus key times key, integer division by 2. And then we want to check if this is less than or equal to n. So if this is true, it means that we can have at least the key complete rows. So then what we do? So we want to find max key such that, so f key is true. Well, and f key plus 1 is not true. So we can do first set the space. So low is 1, and you can have at most n complete rows, right? And then what we do, well, low is less than high, right? So then we can do the mid. So I'm going to do this, add to 1/2, high minus low over 2. And then I'm going to check if f mid. In other words, we can have at least k complete rows. Then we do another check. If not, find mid plus 1. Then this mid is what we should return. So we should just directly return. Otherwise, so if mid plus 1 is still true, we can have at least mid plus 1 complete rows. So in this way, we set low to be mid plus 1. Notice that low is always making this function true, right? Because here mid plus 1 is still true. So then this is the if f mid is true. Otherwise, mid is too large, so we're going to set mid to be 1. Then later, if you haven't got returned yet, so you're going to return low. So this is the full logic. So now let me first run it to test the find is not defined. So here just use f. So yeah, it passes the 2 cases. Now let's submit it. Yeah, it passes all the cases. Actually, it's very fast due to the time complexity. You can do an analysis. It would be logarithm n, right? So with that said, I guess that's it for the current easy problem. So here, let me re-emphasize. So you can solve this problem by a plain while loop. This is routine. Or you can solve it using binary search. So this is what we want to demonstrate in this video. So the reason we do this is that using a very simple example to demonstrate the mechanism of some more advanced algorithm is very helpful. So with that said, I also want to mention that we have a YouTube channel which contains more than 1,000 very well prepared videos or rigorous videos. And especially you can check out the binary search playlist. So hopefully this will give you some more insight or motivation. With that said, that's it for the current video. Thank you for watching.